So in this video, I'm gonna show another example called this is a famous benchmark data set called the MINIST. Data set. So this data set contains about people's handwritings about digits on the envelope. I think the original idea is people want to invent a machine to recognize the zip code people write on the envelope. Okay, so in this example, in this data set, I think we're gonna use this data set in our homework 1, where you're gonna see, know more details about this data set. So actually, in this data set, each digit is a picture. Okay, is represented by a pixel. Pixel in our data set can be represented by a matrix. For example, depends on the colors on that pixel, we have a number to represent. For example, we have I think the first number can be 3. I just made up these numbers. So in your homework, you're gonna see this matrix. 3, I think it's a 4x4 matrix. You can think this is a picture about this digits, and you chop this picture into the small cells, and you check the colors on each pixel. Okay. So the deeper color is the darker, the larger the number is. So suppose this number is represented by this 4x4 matrix. Suppose this is the data we have in this MINIST data set. Okay, so and we want to use this matrix data set to tell. So this will be the input. Is just the pixels of each picture, and the output will be, you need to decide not just a binary classifier, but we have the multiple classifiers. We need to decide it's either 0, 1, 2, 3, up to 9. Okay, up to 9. So it's a little bit different as the previous example. The previous example, we have only 2-dimensional. One x-axis is just a balance, account balance. The y-axis is income. So we have binary. But in this case, you can think of this data set. Actually, later on, we're gonna say we're gonna treat this classifier by not using the matrix, but we vectorize it. Okay, vectorize it. We just write down the first row as a 3, 2, 3, 3. We just write down each row vertically, and 0, 0, 2, 3, and the last few are 3, 3. Okay, so we have the vector of the 16. So the input in this case is 16 dimension. Okay. So the decision boundary so we cannot visualize this one because it's 16 dimension. The decision boundary will not be just a line. It will be a high dimensional hyperplane. Will be a hyperplane. Okay. So we can apply the similar ideas as the previous example. Even though we have more dimension of input and more dimension of the output, but we can still apply the similar idea. Somehow define the distance between, suppose we have a new picture with some number of the pixels. Okay, we can somehow calculate the distance. We can use the nearest neighborhood methods, right? And then we can train our model. Okay, actually, let me summarize a little bit here. I want some space here. So the procedures of the machine learning will mainly contains three main components. One is called a train. You come up with some model like a classifiers. You train your model, okay, and you validate your model. And you want to try your model for the new data set, test data set, okay. So train. So usually your data set is you have the data set at hand. You chop it. For example, suppose this is your data set. Usually, maybe we can say 80%. 80% is the train data, and then maybe 20% as a validate. Data. Okay. And for this data set, we have the labeled data. So we have the labeled data. For example, for each of the numbers, for each of the pictures in our data set, we know this is 1, this is 7. So they are well-trained, well-labeled data set. Okay. We also hold another data set called validate. We're gonna divide the data set at hand into two parts. One is the train data set. One is called validate data set. Okay. We're gonna train our model, train our classifier on the train data set. Okay. So we usually train fit, or another common word is fit. Model on train data set. Okay. And how do we tell if a model is good or not? We check the performance. Fitted model. The performance on validation data set. Okay, so this step is called validation. This step is called validation. Validation. Okay, and then you may ask, what's a test? Test. Test usually is optional. For the new data. So in later homeworks, I will give you some, you train your model and you adjust your model by using the validation data set, okay? And you want to know the performance of your trained model on the new data set, right? So that's where you get the new test data set comes in. But for the new test data set, usually no labels. No labels, okay? That's new future data set. So we want to get our model work best on the test data set. Okay. So that's the basic steps for the machine learning algorithms. And there are three types of errors here. There are usually, no matter which machine learning algorithm or model you use, there are usually three types of errors. Maybe let me write on here. Three type of errors. The first one is the training error. Okay, training error is the error that of your model how your model works on the training data set. So if we look back to our original credit card example, the nearest neighborhood classifier has a perfect classifications on the training data set, right? So the training error for the nearest neighborhood classifier will be 0. Okay. But the linear classifier, even on the training data set, has some errors, right? Because there are some misclassified case. On the defaulted region, there are many blue circles, and on the reliable region, there are many orange circles, right? So in this case, the training error for the linear classifier is higher than the nearest neighborhood classifier. Okay, so the first error is called the training error. Okay, so which means how your data works on the training data set. Second is called the validation error. Okay. So which means in our classification problem, this means the fractions of validations set misclassified. Okay, and we usually use this to tune our models. For example, we can use the nearest neighborhood classifier as an example, right? We can have the one nearest neighborhood on the classifier methods, right? We can have very low training errors, and this is where the linear classifier is. Okay, and you reduce the numbers of the number, so we call it the k nearest neighborhood classifier, right? K nearest neighbor methods. Okay, so actually k here is our hyperparameter. Okay, for example, we can use, we can give a new data point. We can think the closest one data point, or closest two data point, or closest k data point. So this k represents a hyperparameter in our model. Okay, so if we decide to use 1, so we can get a very small training error. But actually, for this model will be overfitting. Actually, it's on the validation data set, the error will be big. Okay. Actually, at some time point, we increase the number of the nearest neighborhood k. This k, we can say the best performance nearest neighborhood classifier is using the 7, which means we pick the 7 closest point in our validation in our classifier. This gives the best performance in validation dataset. As you can see, that's usually the case. You're gonna see such plot a lot when we do the machine learning algorithm. That actually the training error will always decrease if we increase the model complexity somehow, tune it up. But the test error or the validation error will always decrease first, and at the same time point it will come back to increase. Okay, so this error is called validation error. I hope you can get some. We're gonna give more details, more concrete examples about the training error and the validation error in future class. But to now, just give you some ideas. Okay. So the third error is called testing error. Testing error is once you trained your model from the training data set and you tune your parameters in your model by using the validation data set. Now the real performance of your model in the future data set, that error is called a testing error. Testing error. Usually this testing error we don't know. We hope we can get this idea of the testing error from the validation error. So we can use the validation error to approximate this testing error. Okay. And there are some more terminology in the machine learning. One is called overfitting. Overfitting. So for example, if we use the closest one nearest neighborhood classifier, it fits the training data too good. Okay, so it overfits the data set. Okay, and another, on the other hand, the linear classifier is here. Actually, linear classifier is too simple. Okay, so it underestimate. So it's called underfitting. Okay, so we want to try to build a model that to avoid two scenario. This is something we trying to avoid, either overfitting or underfitting. Okay, I think that's all the basic top concepts I want to talk about today, and I know maybe some of you get confused about the validation errors and testing error. In the next few classes, I'm gonna give you more concrete examples about each of the case. That's all for today. Thank you.